Welcome to the Lean Mean Virtual Machine, a new video series by engineers for engineers, where we talk about how to take advantage of edge computing platforms in your automation and control projects. Hello, my name is Jay David. I am the Senior Solutions Marketing Manager for Stratus Technologies. In addition to working various marketing jobs for over 17 years, I also have 20 years experience as a controls engineer and spent many hours designing, installing, testing, and commissioning automation systems all over the world. At this point, we're going to assume that you've already selected your HMI and SCADA software, as well as the PLC, DCS, or hybrid controllers that make up your process control and discrete systems. Everything is already good, but hey, we can make it better. The make it better part is important. In this video, I will be explaining how to leverage edge computing platforms to create better HMI and SCADA solutions. So join me in this short journey. Gartner defines edge computing as part of a distributed computing topology where information processing is located close to the edge where things and people produce or consume that information. As you can see, Gartner has identified multiple levels under edge computing, from the device edge, where you'll find your PLCs, DCS, and other embedded control systems. Gateway edge, where you have the gateways that connect your controllers. Compute edge, composed of edge servers and other plant floor monitoring and control devices. Local and regional data center edge, where you'll find the micro data centers and control room equipment. And finally, the centralized cloud and global data center, where you'll find your command center and enterprise solutions. I look at the Gartner edge computing topology as the edge version of the Purdue model for industrial control systems. Combining the Gartner edge topology with the Purdue model, we produce this, a perfect diagram to show the entire edge portfolio from device, gateway, and compute edge all the way up to enterprise. This diagram is a typical automation and control architecture based on the Purdue model. More importantly, it is an architecture that shows how it is possible to use edge computing platforms at the various levels of the Gartner edge topology. Why is this important? Let's do a deeper dive. For us to understand how to leverage the edge to create better HMI and SCADA solutions, let's first talk about some of the challenges that engineers face when they are deploying or operating HMI and SCADA in their automation and control systems. There are many challenges, but we will focus on a few. Traditional HMI SCADA architectures have been in existence for many years, and they look something like this. First, you have a PLC, a DCS, or a hybrid solution that performs most of the automation and control. Second, connected via a control network are a series of computers that communicate via a device driver. And lastly, HMI and SCADA software provides monitoring and control to facility or plant. This is all good, but as demands for better, faster, and cheaper have increased, especially with the advent of IIoT and digital transformation, sometimes good is not enough. Here are a few challenges. Challenge number 1, the demand for digitalization. As more and more companies embark on digital transformation journeys, the demand for digitalization increases. In automation and control, we see a few trends. First, more and more customers want to turn information into knowledge that they are investing in connecting to more devices to get a much better and accurate reading of what's happening. The same customers want to integrate all their edge solutions to the enterprise, and they want to be able to access that knowledge wherever they are in very different and useful formats. Challenge number 2, disparate islands of automation. HMI and SCADA solutions that are not planned properly result in problems down the road. Over time, as control systems age and more nodes are added because of expansion and upgrades, you end up with multiple computers for HMI and SCADA, historian, MES, APM, advanced applications, and engineering. If not planned properly, they devolve into multiple siloed nodes that are very difficult to maintain and operate. This results in disparate islands of automation, mainly because of poor architecture design. Challenge number 3, unplanned downtime. One of the worst things that could happen to an HMI and SCADA system, or practically any component in your plant floor or facility, is failure due to unplanned downtime. It is very expensive and in some cases may cause destruction of property and unfortunately accidents and loss of life. In mission-critical applications, unplanned downtime simply cannot happen. So, what do you need to do to solve these challenges? The answer? Edge computing. The switch is simple. Replace all the existing computers and servers in your traditional architecture with a single edge computing platform. Most modern edge compute devices come with virtualization and redundancy capabilities. In some cases, they come in with pre-configured virtualization and built-in redundancy. This is important, especially if the location where your SCADA or HMI is installed in a remote or hazardous location, sometimes both, where there are no IT professionals to help you set up and maintain your infrastructure. So what happens when you replace your computers and servers with an edge computing platform? First advantage is that with an edge computing platform, unlike commercial servers, you have a no-compromise compute device that is designed to be deployed in an industrial environment. Second, it can operate in remote and hazardous environments and in some cases are Class 1 Division 2 certified. Third, it is a compute device that provides local control and monitoring at the machine or process area level. And lastly, it is one that you can install in the same control panel as your UPS, DCS, PLCs, and other control equipment. With edge computing platforms that have virtualization built in, you can consolidate multiple HMI and SCADA software together with your other advanced software like Historian, MES, Batch, Asset Performance, and your engineering and programming software into a single device. Applications that would have otherwise been installed in multiple computers. Protection from outside attack, whether it be cyber or otherwise. Most edge computing platforms come with built-in security capabilities like host-based firewall that lets you blacklist or whitelist IP addresses or domain names, restricted USB ports that help prevent spread of malware, role-based access controls that authorize specific users and groups, and secure communications protocols and trusted boot that helps prevent cyber attacks. Lastly, redundancy and downtime prevention. There are many ways to provide redundancy for your HMI or SCADA system, but one of the best and simplest ways is to use an edge computing device that already has built-in redundancy capabilities. Why is this advantageous? Number one, edge computing platforms with built-in redundancy have true high availability capabilities that prevent unplanned downtime from happening, as opposed to recovering from downtime. Second, you avoid having to set up difficult to implement clustered solutions. And lastly, you save a lot in terms of buying additional software licenses. So let's look at the customer success story to show the advantages of edge computing platforms to HMI and SCADA systems. With a 130-year history, Netherlands-based Aliwijnse is a global leader in marine technology for critical ship systems for yachts, naval and government vessels, and dredging offshore and transport ships. The company designs, delivers, and integrates onboard electrical systems, automation systems, and advanced marine electronics. Using edge computing, the company introduced Alvivi, the maritime industry's first future-proof digitalization platform for bridge control of critical vessel systems. The platform relies on application virtualization to drastically reduce its IT requirements and enables ship-wide visualization of information. Aliwijnse sought to solve one of the largest challenges for the maritime industry, that is, simplifying the HMI SCADA architecture required to operate multiple critical ship systems in a very constrained space. rather than deploy and manage multiple computers spread out across the vessel for each control system for propulsion, for energy, navigation, communications, electrical security, and others, Alivansi turned to Stratus to consolidate their HMI SCADA and other advanced software into a single device. What advantages did they get out of using edge computing platforms? First, it simplified their architecture where they can mix and match applications with their HMI and SCADA. Second, they were able to reduce the device count from 20 computers into one server. Third, they were able to improve the solution lifespan from 4 to 8 years. Overall, Alivanse was able to reduce onboard computing footprint by 70% and reduce its customers' IT maintenance costs by 50%. Alivanse is proof positive that edge computing platforms improve the performance and reliability of HMI and SCADA systems. Let's now summarize the advantage of using edge computing platforms in HMI and SCADA solutions. Edge computing platforms enable workload consolidation. What is workload consolidation again? It is consolidating multiple physical assets into a single, more advanced virtualized edge computer or server. Why do you need it? With workload consolidation, you deploy a smaller number of devices to maintain and operate. Smaller number of devices means less panel space and wiring. With workload consolidation, you have all your software assets in a single redundant and industrially hardened edge device. A single device makes it easier to implement solutions in industries that require GMP, validation, and regulation. Operational resilience means preventing unplanned downtime from happening. Your HMI and SCADA software is only as good as the platform it runs on. For mission-critical applications, you really need a platform that prevents unplanned downtime. You need an edge computing platform that provides redundancy that is easy to implement. Operational resilience also means being able to deploy an industrial-grade platform, a ruggedized edge computing platform that you can install in harsh environments with high or low temperature, vibration, and humidity, and in some cases, Class 1 and Division 2 certified. It is something that you can install in a control panel together with your PLCs, your drives, and other control equipment. Operational resilience also means having a platform that helps secure your control infrastructure from cyber attack. Number one, a platform with built-in security features, and number two, has a network of partners that use the edge. So what are the next steps? If you want to know more, there are a couple of assets that you can download right now. First, there is a library of tools to size the right edge computing platform for you based on the software you're using, whether it be Rockwell, GE, Aviva, or Inductive Automation. And second, there is the Alivanse case study that you can download as well. And then lastly, our recommendation is schedule a meeting with one of our subject matter experts and find out if you can do a proof of concept and see for yourselves how the platform works. Before we end, here's something short and sweet about Stratus Technologies. Stratus is a tech company based in Maynard, Massachusetts. We ensure the asset consolidation and continuous availability of the critical applications of our customers. Over the past 40 years, half of the global Fortune 100 customers are current Stratus customers. 5 of the 10 largest global retailers are current Stratus customers, representing over $843 billion in annual revenue. Stratus has been in the business for over 40 decades, and we have over 12,000 systems running continuously around the planet. Our durability and reliability is a testament to the value we continue to provide our customers. Alright, one last thing. If you are right now in a design stage, either in the process of creating a new HMI or SCADA or trying to replace an existing HMI or SCADA system, the question is it worth changing from the traditional HMI and SCADA architecture on the left, one that you know and love, to one based on edge computing platforms, the architecture on the right? I say yes. The advantages of using edge computing platforms just on workload consolidation and operational resilience alone is enough to make the switch. Thank you very much, and until the next video, take care.